Welcome viewers to Elimu TV. This is our mathematics lesson, and in today's lesson we will continue from where we stopped last time, the method of completing the square. Now, when we are dealing with quadratic expressions, remember we have three terms in a quadratic expression. The first one is what we call the quadratic term. Why? Because it has x squared in it. The second degree, so it has x squared in it. The next one is the linear term. Is the linear term, that is the second term, which we are calling the middle term. This is the first term. And then we have the last term, which is a constant. Last term, which normally consists of a known value or a known number. Okay? And so this basically is the formation of a quadratic expression. Now, we stopped with the first method, if you remember, on that is when the quadratic term has a coefficient equals to 1. But today, we are going to talk about how do we complete the square if the coefficient of the quadratic term is not equal to 1. And the formula we use for that matter is the last term is equals to the middle term squared divided by 4 times the first term. Now you remember in our previous lesson, we were adding the third term or the last term in order to complete the square. And we said, what we mean by completing the square, it means writing this expression such that it can be expressed as x plus a squared. So if we can write this expression, add a value here such that it can be written as x plus a whole squared, then we have completed the square. In other words, we have made it a perfect square. And so that is what we are going to look at in this lesson. Now, supposing you are told, you are given 4x squared plus 10x, and you are told to complete the square. How do we go about it? Now, if you look at this expression, the third term or the last term is missing. So plus the last term. So going by our formula, the last term will be equal to middle term squared divided by 4 times the first term. Okay? So that means you take the middle term, you square it, then divide that by 4, multiply by the first term. So let us do that. So you enter the middle term squared. So it becomes, if we have 10x squared, it becomes 100x squared. And then divide this by 4 times the first term, which is 4x squared. So now we can cancel the x squared. We have 4 by 100, we have 25, and therefore, what we need to add, the last term, will be 25 over 4. Okay? So you can see now, we may now write the last term since we have found what it is. So I'm going to rewrite the expression including the last term which we have calculated. So it will be 4x squared plus 10x plus 25 over 4. So what this means is that we can now write this term, this expression, in the form x plus a whole squared. Before I tell you what it is, I want to see whether you remember from the previous lesson how we did that. So try and write this. Take a few seconds to write this as a perfect square. So the answer should be, get the square root of that, which will be 2x, and the square root of 25 over 4, which should be 5 over 2. The sign in between should be the sign in front of the linear term, which is plus, and then the whole of that squared. Did you get it? Yeah. So now this is what we are talking about. That this term is a perfect square because it can be written as 2x plus 5 over 2 whole square. In other words, just as we can write 4 as 2 squared. So we can say that 4 is a perfect square because it can be written in the form 2 squared without a decimal. Similarly, we can write 9 as 3 squared. We can write 16 as 4 squared. So 9 is a perfect square, 16 is a perfect square, 4 is a perfect square, 1 is a perfect square, 100 is a perfect square. Now, that is method 1. Method 2 of doing the same thing, there is a second method. Now, in the second method, we simply add, we say the last term should be equals to b squared over 4a. Now, where does the b come from and the a? I am taking the general equation, the general expression of a quadratic expression. It is ax squared plus bx. Now, so we have a and b. We need to find what to add to this one in order to make it a perfect square. And we are saying that last term that we need to add there to make it a perfect square is b squared over 4a. So that it now becomes ax squared plus bx plus b squared over 4a. Now, to exemplify that, I want to take the same example we had earlier. 4x squared plus 10x plus LT. So we have seen that LT will be equals to b squared. What is b? B is the coefficient of x. In this case 10. So we write 10 squared, which is 100, divided by 4 times a. What is a? A is 4. Cancel 25, and the result is 25 over 4. Now, you can see we get the same result. We get the same result as before. Now, according to you, which one is easier? Method 1 or method 2? There is still a third method. So I will now give you method 3 of solving this. You are given 4x squared plus 10x, and you say, let the number that need to be added be equals to k. Then you say, this one has to be written, for it to be a perfect square, it has to be written as x plus a whole square. So now, expanding the right-hand side of this equation, we have 4x squared plus 10x plus k is equals to, when we expand this the usual way, we get x squared plus 2ax plus a squared. And then, since these two expressions are equal, we now compare the coefficients. The coefficients on both sides. Now, this one will be, this should be 2, and so this will be 4. Now, comparing the coefficients, the coefficient of the middle term, we have 2a there must be equals to 10. And therefore, we write that down. 2a is equals to 10, which implies that a is equals to 5. Okay? Then k will therefore be a squared, which is equals to 5 squared equals to 25. Equals to 25. And therefore, when we now bring the value of k, so the value of k in this case becomes 4x squared plus 10x plus 25. But that is different from what we had before. Why? Because the coefficient of x squared is equals to 4. So if we divide throughout by 4, we'll get x squared plus 10 over 4, x plus 25 over 4. Now I'll give you another example of method 3. You are given 9x squared plus 10x plus k, and you are told is a perfect square. So find k. So you will say, let 9x squared plus 10x plus k be equals to the perfect square. So the first one will be, of course, the square root of 9x squared, which will be 3x, plus an unknown a. This should be squared if it's a perfect square. So expanding the right-hand side, we'll have 9x squared plus 2 times 3x plus times a, that becomes 6ax, then plus a squared. So from there, we will say the middle term. The middle term compares with this. This compares with that. And therefore, we write 6a is equals to 10. 6a is equals to 10, which leads us to A is equals to 10 over 6 or 5 over 3. And therefore, A squared, that is the last term, will be that squared, which will be 25 over 9. And therefore, we can write this expression as 9x squared plus 6 times 5 over 3. 6 times 5 over 3 x plus 25 over 9. You cancel that, and this becomes 9x squared plus 10x plus 25 over 9. And this will be a perfect square, which can be written as 3x plus 5 over 3 whole squared. So now, to give us a few more examples, we have seen that there are three methods. There are three methods. One, the first method is where you say the last term is equals to the middle term squared divided by 4 multiplied by the first term. This is method 1. Method 2, we have said you simply add the last term will be b squared over 4a. And the third method is comparing by comparing of coefficients. Comparing of coefficients. I want you to attempt this one. You are given, make 4x squared plus 2 over 3x a perfect square. Use any of the methods that we have discussed. LT is equals to MT squared over 4 times FT, or LT is equals to B squared over 4A, or comparison of coefficients. Now, you solve that. Let me, okay, let's see what you are supposed to get. Now, solution. Solution, see whether you have gotten the same thing. Now here, if we use the first method, you say the last term is equals to this squared, which means 2 over 3x squared, sorry, the middle term squared, the middle term whole squared, divided by 4 times the first term, 4x squared, which will become 4 over 9x squared divided by 16x squared. X squared goes with x squared, and you have 4 over 9 over 16. 4 over 9 over 16, it becomes 4 over 9 times 16 by 4 by 4, and so this becomes 1 over 36. So is that what you got? I hope so. So if you got that one, then you have understood and followed the lesson. Now, so this expression, when you finally write it, you are supposed to get 4x squared plus 2 over 3x plus 1 over 36. Now, can you write this one now as a square of a given expression? Can you do that? Now remember what we said. You get the square root of the first term, 2x. The sign in between should be the sign in front of the middle term, and then the square root of the last term, which will be 1 over 6. Therefore, this expression can be written as 2x plus a sixth whole squared. And so that basically is the method of completing the square when the coefficient of x squared is not equals to 1, or when the coefficient of the first term is not 1. And so that brings us to the end of this lesson. In our next lesson, we will continue with the method of completing the square and look at some more advanced expressions. Thank you.